All right, welcome back. I hope you had a good spring break. This will be Polynomials Part 2. You'll take another quiz grade in this. I'm going to use GimKit this week, and then next week you'll have a test on polynomials after we go over multiplying. So it'll be on classifying, adding, subtracting, word problems, and multiplying. But just a quiz this week. All right, so remember classifying polynomials. They can be classified or named by the number of terms. So we had a monomial, a binomial, and a trinomial. And remember, if it's more than 3, we just call that a polynomial. Now, another thing I wanted to add that I found in the algebra curriculum is they also name the degree. So we classified by the degree, but we didn't specifically name it. So I want to give you a little bit of exposure to that. So the first polynomial is negative 24. That has a 0 degree because there's no power of x. We just call that a constant. You should already know that. The second class is linear because if you see we have 2x minus 8. Anytime x is to the first degree, that's called linear. You already know that. That's some previous knowledge there. Then we have 3x squared minus 7. That is the second degree. You should already know that we call that quadratic. Remember we kind of talked about it being odd because quad usually means 4. But here a degree of 2 means quadratic. It comes from Latin like quadri or quadriosis means square. Quad in Latin means square, so since that's x squared or to the second power, that's quadratic. So you can kind of also remember the graph of these, of a quadratic function, is that U-shaped graph, where linear is a straight line, okay, and constant is just a point. So next we also have to the third power. Okay, this is called cubic, obviously because we're cubing this. If this were on a graph, it would look like that crazy kind of S-curve graph we kind of previously talked about. So these are your 4 new vocabulary words. Really none of them are new. I just need you to understand that they match up with the degree. Degree of 0, degree of 1, degree of 2, degree of 3. So we can use this to classify some terms. All right, so let's look at the first one. They give you the polynomial. They want you to put it in standard form. Remember, we go from the highest exponent to the lowest. Classify the degree, number of terms, and the actual name. So this one, I would rewrite this in standard form. This would be negative 6x to the third plus 5. That has a degree of 3. Number of terms here are 2. So this would be a cubic binomial. Cubic meaning a degree of 3, binomial meaning a degree of, 2 terms. So negative 4, that is the standard form. The degree is 0 since there's no x. It only has 1 term, so that is constant. This one has 2 terms, standard form. My x would come first, so this would be 5x minus 10. Degree would just be 1 here. That's the degree of my x value. It does have 2 terms, so this would be a linear, because it's a degree of 1, binomial, because it has 2 terms. Next, we have 8x minus 2 minus 6x to the third. So in standard form, my highest exponent is negative 6x to the third plus 8x minus 2. I'm just rearranging that. So it has a degree of 3, and it has 3 terms. 1, 2, 3. So this is a cubic trinomial. So I'm just adding this first name here. Anything else, like if it were 5x to the 5th, that would have a degree of 5, 1 term. Would just call that a monomial because there's no specific name for anything above x to the third. Okay, so you just need to know constant, linear, quadratic, which would be anything squared, and then cubic, anything to the third power. So just adding some to the classifying. Most of you did very well on adding polynomials, but I just wanted to review it. Remember, this is just combined like terms. Okay, so we'd find like terms here. We have 4x squared and x squared. That would give us 5x squared. We have negative 2x and 3x. Negative 2 plus 3 would give me 1. So I could just put x. and 8 minus 2 gives me 6. I really feel like y'all did very well on the quiz last week with this, so I'm not really going to review any of these. Oh, I'll do this one and I'll be done. I'll review one more. So 4x squared and 2x squared gives you 6x squared. Negative 2x and 2x cancel out, so you don't put anything. Do not put 0x. That's just 0. Nothing is there. And 8 minus 5 is 3, so 6x squared plus 3. I feel like y'all are really good with adding. Now, a lot of you had some issues with subtracting. A lot of you missed the subtracting problems over and over again each time you tried the quiz last week. So remember, when you're subtracting, you have to distribute this negative. You can imagine if there was a negative 1 there and distribute it. What I think happened last week is some of you were just trying to rush through it and be careless, and you did not distribute that negative all the way through. So this would remain 2x squared minus 2x plus 3. Then I would distribute the negative. That would give me negative x squared minus 5x plus 5, because negative 1 times negative 5 is a positive 5. Now I will combine like terms. 2x squared minus x squared is x squared. Negative 2x minus 5x gives me negative 7x. And 3 plus 5 gives me 8. One incorrect answer here that people would pick would be x squared minus 7x minus 2, because they're just careless here and they say, oh, negative 3 minus 5. I'm sorry, positive 3 minus 5. So be careful. We know what mistakes you'll make. Just because you see it on multiple choice does not mean it's correct. Same thing here. Distribute all the way. Negative x squared minus 3x plus 1. Combine your like terms. Gives you x squared minus 7x plus 9. Distribute the negative. Negative 2x squared minus 6x plus 1. Once you distribute, combine like terms. 4x squared minus 10x plus 2. Last time here, distribute that negative. Negative 5x squared minus 2x plus 2. That gives you x squared minus 4x plus 4. So just be careful when you're distributing the negative. All right, all that should be review. One thing I wanted to point out, when we have multiple variable operations, like multiple variables in one expression, when you combine them, they have to match exactly. For example, this has 4x to the third, y to the third. Whatever like term I will combine it with has to have x to the third and y to the third, exactly like that. So this one right here works, so I'm going to combine 4x to the third, y to the third, and negative 2x to the third, y to the third. That's going to give me 2x to the third, y to the third. Now I'll check. I'll use a different color. 3x squared y. The only x squared y I have is right here. So 3 minus 4 gives me negative x squared y. I have 8xy all by itself. And then I have negative 4 plus 8, which is 4. So be very careful. In standard form, this is correct because I go alphabetically by x first, x to the third, x squared, x to the first, then my constant. So here, same thing, a to the fifth, b to the fourth. I don't have another one, so that stays. 7a to the fourth, b to the fifth. These are not the same, so it cannot combine. And negative 18a to the ninth. So really, you might be thinking, well, there's nothing to do there. You need to put this in standard form. So I go alphabetically. The a should come first, and then the highest exponent. So I have a to the ninth, fourth, and fifth. So really, negative 18a to the ninth will come first. Then plus 3a to the fifth, b to the fourth, and then plus 7a to the fourth, b to the fifth. So just be very careful when you have multiple variables. Make sure their exponents match before you combine them and put it in standard form. Next, we're going to have some application problems here. Find the perimeter of the rectangle. Remember that perimeter means we're going to add all of the sides. So we're going to have 2x minus 4 plus 5x squared minus 4x plus 8 plus my other side. So these would be the same and these would be the same. So really I'm going to do this twice. 2x minus 4 plus, I'm running out of room, 5x squared minus 4x plus 8. And if you can just go around this and fill it in and not write the expression, I'm fine with that as well. Okay, so combine like terms. You might want to just go ahead and start with your highest exponent, 5x squared and 5x squared. That gives me 10x squared. We'll go to my degree of 1s now. 2x minus 4x plus 2x minus 4x gives me negative 4x. Next, I'm going to do my constants. Negative 4 plus 8 plus negative 4 plus 8 again gives me 8. This does need a unit, centimeters. It is not squared. I did not multiply anything. I'm just adding all the way around. So to find the perimeter, you add all the way around. You just add each expression and combine like terms. Let's practice one more. Like that, you may be able to just visualize this. I have no x squared, so I'll just combine like terms. So I'll have 4x, another 4x, 2x, another 2x, so that's 12x. Now my constants, 8 plus 8, that's 16, plus 3 gives me 19, plus 3 more gives me 22. There's no unit here, but I still need to write units on the end. It's not a specific unit, so we just write units. So that's finding the perimeter of a rectangle. And this could be of any shape. It could be a triangle, it could be a square. You just add all the sides and combine like terms. Next, we have some polynomial expressions in the real world. Ms. Griggs wants to maximize her production of T-Rex products. Currently, her company, Triple G's T-Rex, makes 3 different sizes of products. There's a large T-Rex that costs $85 to produce, a medium T-Rex that costs $55 to produce, and a small T-Rex that costs $25 to produce. Create an expression to represent the total cost for production. So I'm making an expression. That means I'm going to have some variables. I need to define my variables. So I have a large T-Rex, a medium, and a small. So for me, L is going to represent the large T-Rex, M will be the medium, and S will be the small. You can use whatever variables you want as long as they're not the same. Like, for example, you can't use T for all 3 of them because they're different things. So my large T-Rex cost $85, so that would be 85 for my large ones, plus 55 for my medium, plus 25 for the small. I probably shouldn't use this, but I'll make it look curly. For the small T-Rex. This is my expression. I'm just representing my variables as letters to match each product, each different one. If the company produces 3 large, 2 medium, and 1 small T-Rex in a day, what will be the production cost for that day? So we're just going to plug this in here. This is 85 times the large, there were 3, plus 55 times the medium, there were 2, plus 25 times 1 for the small. And that will give me the total production cost. I guess it should be production cost for that day. So I have 85 times 3 plus 55 times 2 plus 25. So $390 would be the production cost for that day. And really, word problem needs a word answer. So the production cost for that day would be $390. The expression would be 85L plus 55N plus 25S. So that should help you out on the GIMP kit. If you need any questions, feel free to email me or send me a message. Thanks.